Hello, my name is Tyler Strawn, and this is my lean sandwich shop case study presentation, where we will be examining the efficient inefficiencies and processes of the lean sandwich shop. You know, the current state and current issue of the lean sandwich shop, they have a demand of 600 sandwiches per day, which is 218,400 sandwiches per year. The big issue with the sandwich shop is that 10% of these sandwiches are scrapped. Um, 60 sandwiches out of 600 a day are thrown in the garbage and wasted uh, due to reasons we will get into. But this absurd scrap rate is resulting in an annual cost of failure of $120,120. That is quite a high cost and a high scrap rate for making sandwiches. The current process that is yielding these results consists of 7 tasks. We have record and deliver the order. Task 2 is receive the order, select the bread. Task 3 is to add protein. Task 4 is to add vegetables and toppings. Task 5 is to place the sandwich in the toaster. Task 6 is to wrap the sandwich. Task 7 is to deliver the sandwich to the customers. And here's a breakdown of how many employees are completing each task. So we have 3 to task 1, 1 employee to task 2, 1 employee to task 3, 2 employees to task 4, 3 employees to task 5, and 1 employee each for task 6 and 7. The total amount of employees we have are 12. The whole process is taking 600 seconds with a takt time of 60 seconds. And this current process is yielding a throughput of 5. Now, when examining this process, there is a lot of waste that comes to the surface. First, on our Pareto chart, we have the most common reasons that sandwiches are being scrapped. Far and away, the most common is that of a cold sandwich. Of course, a customer is not going to be happy taking a bite into a cold sandwich. The second is the wrong dressing. The third and fourth are spoiled toppings and wrong toppings. And the fifth is the wrong sandwich. But as mentioned, far and away, the cold sandwich is the biggest issue. Now, when looking at our work balance chart, we can see that each process cycle time varies from the last. There's a very high variation, even from process to process. This creates inefficiency, and especially when we have a 15-second process and process 2 immediately followed by a 90-second, which is serving as quite a barrier. With our work balance chart, we're also able to calculate the optimal number of employees for this process. Should be 10. 10 is the optimal number, but we are currently employing 12, which is 2 over that optimal amount. Now shifting down into our work combination chart, we have a lot of waste with regards to toasting. It would appear that our employee is taking the sandwich, putting it in the toaster, and then standing around and not being productive in any way while they are waiting for that sandwich to be done toasting. That is creating a lot of time wasted and, of course, aiding to the inefficiencies in this process. This waste analysis is super important because it really paints a full picture of what we are doing wrong, without which we cannot hope to progress. After analyzing the waste, I've come up with a few recommended solutions in the form of capital investments. The first big one is a conveyor belt toaster. So this will have a 90-second toast time, which is significantly less than our current toast time. It will allow us to toast two sandwiches side by side. But the big advantage to a conveyor belt toaster is that it is continuous. So we are not placing a sandwich and then waiting for it to be done before we can use the toaster again. We can simply add more on as that conveyor belt keeps pushing these sandwiches through the toaster. This means we're not waiting. We are not waiting for availability of the toaster. Another advantage is that these toasters are highly customizable with temperature and speed. Temperature, of course, at which the sandwich is being toasted, and speed of the conveyor belt. And then the final advantage I have listed here is that it pushes the sandwich right out onto a tray when it is finished. So um, this almost fully automates the toaster process, with the exception of putting the sandwich on the toaster. We don't have to worry about that burning or undercooking as we're able to customize it. It will simply push that sandwich right out onto the tray. And the most common complaint for scrap sandwiches is being cold. So not only will that sandwich or will that toaster push the sandwich right onto the tray, but another there will also be a heat lamp, which I've recommended to be aimed right at that tray. And so that these sandwiches are coming right out of the toaster and are remaining hot until our employees are able to take that hot sandwich and wrap it and deliver it to the customer right then and there. Another capital investment, a smaller one that I have suggested, is color-coded dressing containers. The wrong dressing was the second most common reason for sandwiches being scrapped, which I have decided to address in this manner. Hopefully, having color coded will decrease that, so we know we're more aware of what dressing we are grabbing as we are putting them onto the sandwich. Along with our capital investments, I have proposed a process redesign. I've condensed our current process of 7 steps and shrunk it down to 4. These tasks are task 1, receive and deliver the order. Task 2 is select the bread and add protein. Task 3 is add vegetables and toppings and place in the toaster. Task 4 is to retrieve from the toaster, wrap, and deliver to the customer. So I proposed condensing a lot of our previous 7 while not missing any, but piling them on or keeping them a little more condensed so we have only 4. Now here is what the process flow of the new task would look like. The red is representing the flow of the sandwich, while the little brown circles are representing the employees. So we have 2 employees manning the cash registers, taking orders, collecting payments, where it is moved into task 2, where they're able to collect the bread and add the protein, where it slides down the table into task 3, where our employees are adding vegetables and toppings and placing it on that conveyance toaster. Task 4, you can see the 2 employees down there at the bottom are taking the sandwich off of that tray that is under the spot heater and wrapping them and delivering them to the customer. Now with our new work balance chart, we can see this new process significantly decreases the variation of our process cycle times. Ideally, they would be all level, and while we're not perfect, we have taken a dramatic step in that direction. Not only have we been able to level out some of that variation, but we've been able to decrease the longest process cycle by 30 seconds. So that is great news, showing a much more equitable distribution along with a shorter process cycle time. Now, what will this new process, what will these results look like? So the new process cycle time is 440 seconds, and the task cycle time is 530 seconds, significantly shorter than they were, with a throughput of 2.5 more at 7.5. So we're doing more in less time while implementing this new process and these new investments, we're able to complete a lot more efficiently. Um, with our number of employees, so we are shrinking our force by 4 FTEs, and that calculated in annual labor hours is 14,560. And the cost of those 14,000 hours is 218,400. So just by not even touching the scrap rate, just by optimizing our process for the number of employees we have saved $218,400, which is tremendous. And that's without even addressing the big issue, just by optimizing our process for the number of employees. Now, with our new capital investments of the conveyance toaster, the spot heater, our color-coded dressing containers, and I've also implemented a 555 audit, allowing us to observe, coach, and re-observe, because we really want to trim that scrap rate down from 10%. That is just too much. I have established our goal to be a 2% scrap rate. Now, accomplishing this goal will look like obviously a difference in 8% of scrap rate, which is about 17,472 sandwiches. Now, the cost of those 17,472 sandwiches is $96,096. So we are dramatically decreasing the amount of money that we are just throwing in the garbage. So between increasing our 10% scrap rate to 2%, or decreasing our scrap rate to 2%, while optimizing our process for the number of employees, these recommendations will save Lean Sandwich Shop $314,496 annually. These are tremendous savings, and that's not taking into account the amount of patient satisfaction, or the amount of customer satisfaction, which hopefully they'll continue to come back as they'll have a better experience, and hopefully their sandwich hasn't been thrown away. So just by implementing these recommendations, we have a tremendous savings as well as a reputation building as well. So that is my solution to our Lean Sandwich Shop case.